Today we're looking at topic 2-2 in our textbook. We're going to learn about bar and line graphs today. Our goal is to be able to display and analyze data using both bar graphs and line graphs. Before we start looking at the different types of graphs, we need to have a good understanding of some vocabulary regarding graphs and charts. The first word that we need to be familiar with is data. Data, or data, is a piece of information. It's often numerical, and it can be shown in a table. It's often shown in a table. The next word that we want to look at is graph. A graph is simply a visual way to display data. So you take the data or data and you can put it in a graph, and that gives people a graphical representation or a visual representation of that data. A bar graph is a type of graph, and it's used to compare data. It's very important to understand the purpose of a bar graph is to be able to compare data. Frequency is the number that an item occurs inside of data. So if you're collecting a bunch of information and the number 10 keeps popping up, the number of times that 10 pops up, that is its frequency. The other graph that we're going to be learning about is, and the other type of graph we're learning about today is a line graph. And line graphs are used to show how a set of data changes over time. Okay, we're looking at how the data changes over time. Very important to understand. Bar graphs are used to compare data, where line graphs are used to show how data changes over time. Okay, so I have a bar graph over here. And let's zoom in a little bit and kind of look at the bar graph and see what kind of information we can tell by this. Okay, so our bar graph has a title on it, and the title is the U.S. roller coasters. This is our title. Okay, right here it talks about the different types of coasters. So we have inverted, stand-up, steel, suspended, wild mouse, or wood. And then the number of roller coasters that are out there. And you can notice here, this is the frequency. And the frequency is always on the vertical axis. The frequency is on the vertical axis. The categories are on the vertical axis. There are spaces between our bars. That's part of a bar graph. And you can see our scale here. The numbers are on the lines, and they go by the same interval. The interval is the distance between each number. So 50 to 100, 100 to 150, 150 to 200, 200 to 250. There is an interval of 50 on the scale. So our scale is indicated here. We talked about the scale and the fact that the scale is consistent. The vertical axis, that's the up and down axis, and that is always shows the frequency. The horizontal axis is this one right here, and it shows the categories. Titles and labels, we always have titles. We label all of our data so that we know what we're looking at. And we talked about intervals, and those intervals are the spaces over here on our scale, the distance between each number on the scale. All right, so now we are going to make a graph of this data. So we want to compare the number of students. Okay, so we're going to make a graph of this data. Let's take a closer look at the data so we can see what we're looking at. Okay, so we have a title on this chart of our math scores. And it is saying that we get A out of, I guess, the number of grades we've gotten. We have 10 A's, we have 13 B's, we have 7 C's, and we have 2 D's. Okay, so let's look at the distribution of our data. Our lowest number we need to look at. The lowest number is 2. The highest number is 10. We need to look at this because this is going to help us with our scale on our vertical axis. We have 4 different categories, A, B, C, and D. Okay, let's take a look and see what we get here. All right, so I am going to make a vertical and a horizontal axis. I'm going to name my chart Math Scores. And these are going to be my grades here. And our frequency. Frequency is the number of times. Okay, the top number is 13, so I'm going to actually number up to 15, and I'm going to go by fives. So if that's 15, this would be 10, this would be 5, and there is 0. Okay, my categories A, B, C, and D. Extend that out just a little. So I have 10 A's, so I'm going to come up here to the 10, and I'm going to show how many A's I have. I'm going to draw a bar, come down, and I'm going to fill in my bar. And I'm going to go ahead and write here that I got 10 A's. B's I've got 13, so that's between 10 and 15. So the halfway point is about 12 and a half, so it's going to be a little bit above the halfway point. So I'm going to draw my bar right here. And those are that's how many B's I've got. And that was 13. Okay, then I come over to my C's. I've got 7 C's. So that's between 5 and 10. It's a little bit closer to 5 than it is 10. Okay, then D's, I got 2 D's. Okay, so we said that bar graphs are used to compare data. So if we look at it, we can say that most of our students are A and B students. So we have more A's and B's than anything else, and most people make B's, then A's, then C's, and fortunately D's are the lowest on our level there. Okay, so now we have another example. This is a line graph. And on our line graph, we have a title. We have our vertical axis. And the vertical axis, again, is looking at frequencies. You can see our scale is, again, consistent. We're numbering by tens. This line is 10, 20, 30, 40. It's a consistent interval. Our horizontal axis indicates our years. And we're looking at the years from 1925 to 2000. And they're going in spans of 25 years, 1925 to 1950, 50 to 75, and 75 to 2000. So if we look at our data, we can see we've got a pretty good little increase between 1925 and 1950. We almost have 10 new roller coasters being built. And then between 1950 and 1975, something happened. And it looks like maybe we built 1 new roller coaster. And then look at this crazy roller coaster boom between 1975 and 2000. This 20-year period, we had an increase. It took us from 20 roller coasters to almost 80. We've got almost 60 new coasters here in that 25-year time period. It'd be interesting to research what was going on and why such a big increase in roller coasters happened. Okay, so we talked about the scale and the interval and being sure that that's consistent and always labeled. Titles and labels, we have titles, we have labels, year, number of coasters, points. So what's different about a line graph than a bar graph? Our bar graph uses bars to indicate a frequency of a certain category, where this one you use points for your actual data. So I knew in 1925 that there were a little less than 10, in 1950, 1975. So these data points were actually taken and they were plotted where they belong. And then time. Your horizontal axis is always showing time. Okay, we're always looking at a change over time. So we talked about the change in the wooden roller coasters from 1925 to 1975. And we see here we only had a growth of maybe 10 coasters, and then all of a sudden there was a growth of 60 over the next 25-year period. Okay, so we have another example of a line graph here. So our data that we're looking at is water consumption. So in the year 1960, we consumed 61 billion gallons of water, and so on throughout the data. So what's really important when we're making these tables is 61 billion. If we were to have to plot our graph at 61 billion, it's 61,000 million billion. Okay, this is a huge number to try to write on your scale. So you can actually indicate your scale by using the words to let us know that it's in billions of gallons. Okay, so let's look at the chart that let's look at the graph that corresponds with this table. Okay, so it does need a title. The title should be water consumption. Okay, down here, this is our time, which is years. This is our billions of gallons. Okay, now we can have a pretty good idea of what we're looking at here on the data. So 1960, it gets plotted. Okay, so we want to look for trends. That's the whole purpose of a line graph, is to see what the changes were over time. So if we look at this data and we take into consideration at the very beginning, we kind of look at this first information here. Okay, from 1960 till 1980, this right here, it's a pretty constant increase. And then all of a sudden, something wacky happens, right? I don't know what happened, what was going on in this time frame. But look at this. All of a sudden, the water consumption, it drops. So it goes from this constant, steady increase for 20 years. This is a 20-year constant increase. And then all of a sudden, it falls. And then it starts to gradually go back up. And it takes another 15 years to get back to where it was previously to that drop. So, you know, what happened? Was this suddenly bringing into effect the water conservation? That would be interesting to take a look at. What causes something to have a constant rise and then drop and then start going up again just gradually instead of real high like that? Okay. Okay, now it's time for you to try the moment you've been waiting for. Okay, so you are going to make two graphs. First, you're going to make a bar graph of the data in chart 1 with the U.S. endangered species, and then you're going to make a line graph of the basic cable subscribers on the second one. Go ahead, pause it, make your graphs, remember all of your labels, your scales, your intervals, your titles, everything like that. When you're done, push play, and the key will be on the next slide. I'm progressing to the next slide now. Okay, take a look at this. Take a look at your graphs. See if they match up. I apologize, the second graph doesn't have a title on it. I didn't have the ability to get that to fit in there. Write yourself a summary. And rate yourself. And have a wonderful evening.